Number 9 on the RAP quiz that we just finished is worthy of discussion. Several teams missed it on the individual item analytics that showed up as an issue. So did number 10, but number 10's just straight out of the book. Just reread that last part of that last section in chapter 5, and you'll have that. Anyway, the Lorenz curve bears some discussion. So anybody working with working to study income inequality or wealth inequality will deal with Lorenz curves because they tell us just so much about an economy. Anyway, the idea of a Lorenz curve is that we plot in this 100% by 100% box. We line up everybody in the society that we're looking at, from the person with the smallest share, whether it's income or wealth or whatever, to the person with the biggest share. We line them up in order. And then we plot on the vertical axis the cumulative share. So if the person standing at right exactly the 10th percentile, if they and everybody below them collectively have 10% of the wealth, and if at 50%, they and everybody below them have 50%, we're on the 45-degree line. Perfect equality. And then notice that the pirate ship didn't deviate much from that 45-degree line. A little bit. The captain got a bigger share than the ordinary seaman, but just a couple mates got a 1.5 share, and then everybody got the same share. Very, very egalitarian. British Navy ships, not so equal. The captains got compensated very, very well, and the first mates very, very well, and the average seaman's not so well. That society we talked about in class, where I had all the $1 billion, 98 percentile, that would be the 49 of you, would have 0, and then me, the last person, the last 2%, would have 100. So it would be this line straight across and then spiking up. Very, very unequal. Anyway, so that's the Lorenz curve, and again, the bow away from the 45-degree line tells us how unequal an economy is, or a very small bow, how egalitarian that economy is. The Gini coefficient is just a distillation from the Lorenz curve information. If we labeled this area A, let's talk about the British Navy ship Active, and this area B, so the area between the 45-degree line and the Lorenz curve is A, and then everything else all the area below the 45-degree line is B. The Gini coefficient is simply A, the area in A, divided by the area of B. And so if the Gini coefficient is very small, we know that, like it would be for the pirate ship, that little sliver between the 45-degree line and the pirate ship Lorenz curve is very small as a fraction of this entire area under the 45-degree line. So that's what a Gini coefficient is. So when we get to the question, the distribution of income on the British Navy ships was more equal than the distribution of income on the pirate ship? No way. Quite the opposite. Very equal, very unequal. So that makes 2 correct. The distribution of income on the British Navy ships was less equal than the distribution of income on the pirate ship Royal Rover from this Lorenz curve information. And then let's go to 3 and 4. The Gini coefficient for the pirate ship Royal Rover was higher than the Gini. No. For the Royal Rover, it'd be this teeny area divided by this big area. It'd be very small. For the Navy ships, either one of them, it'd be this relatively large area, A, divided by this entire area, A and B. So that would be a much bigger number. So 3 is out. But the Gini coefficient for the pirate ship Royal Rover was lower than the Gini coefficients for the British Navy ships. Absolutely. So 2 and 4 are correct. That corresponds to number D, or letter D. That's our answer.